Yeah, calculators, because we're going to be doing radicals, it's kind of nice if you can, figure out some factors really quick for the different types of radicals we're going to be doing. Goal today, I want to start with doing cube roots, quartic roots, because we didn't do any of those yesterday. Keep in mind that simplified version, that method we did. I want to review the second method, which I think I hinted at, but I didn't really do. Do the second method of simplifying a radical, because some people like a different method than the one I provided, because the one I do takes a lot of general time, because you have to break down everything as far as you can. I think it's mindless, but especially with a calculator, but some people want to see that second one. Then we have to talk about adding, subtracting, multiplying, and dividing radicals. That's where we're going to leave you. And then I'll give you time where you can work on your homework. You do have homework today. It's on the board. It's due Friday. So you have a couple days to work on it. I think it's really straightforward. Especially if you know how to do radicals, it's not really that difficult. There's a couple that have variables. We're going to review that today, just so you know how to do letters. Because I think if you stick with my method, that method number one I did yesterday, variables are pretty straightforward until you get to the ones with fractions. So here we go. Let's start with the basic concepts of what we're doing today. So if I ask you to simplify the square root of 24, two methods of doing this. Number one, the method I did yesterday. So this is method number one. This is where you break down 24 into the prime numbers where you can't break it down any further. So 24 is, let's say 2 times 12. You break down 12 even further to 2 times 6. You break down 6 even further to 2 times 3. Like, without thinking about it, you go as far as you can. Once you're at the bottom, and you can't break down because I'm only at prime numbers, then what you do is you look at the index number. What's my index number on my particular problem?
2.
A 2. Since they don't have it printed, it's a 2. That means you're looking for pairs of numbers. That's what this number means. Pairs of numbers, two numbers that match. Oh, I have a pair of 2s in here. Doesn't matter which ones I circle, I have a pair of 2s. So the trick was, you kick one of them out, you cross one out. So when I kick it out, here's what I'm left with. There's a 2 on the outside. That's a leading coefficient. You have the radical still. And then the things that are left on the inside are the things I didn't circle. Well, you had a 2 and a 3 still left on the inside. So those are just multiplied together. If you have multiple numbers on the outside, those are multiplied together. So your final answer here is 2 root 6. Questions at all about how to simplify? Simplest radical form. You feel comfortable with that? Okay, method number 2. I'm going to pick a new problem. Let's say I pick the number 72. Okay, method number 2. So we could do this by method number 1 again, but I don't want to. This is the second method. Second method is where you use that perfect square list and you try to see what is the biggest, largest perfect square that goes into 72. So if you look at the perfect square list that I gave you yesterday, let me put these down real quick. I think I have them listed on the website in case you want to know from yesterday's notes. The perfect squares were 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. 121, you get the idea. Okay, now obviously, I'm not going to have to go past 64, because anything past 64 is going to 72.
36.
Yeah, I would start here and try to divide 72 by each of these numbers until you find the number that works. I know for a fact 36 works. It's 36 times 2. And here's the easiest way you can do it. Once you found the biggest perfect square that goes into it, then what you do is just take the square root of that number. What's the square root of 36? 6 root 2. There's your answer. Once you find the largest perfect square, you just take the square root of that, because we already know that number. It's a nice clean number. So the square root of 36 is 6. That goes to the outside, and then whatever was left on the inside just stays there. That's method number 2. Some people like that. The reason why, it takes less time than doing this, but it takes way more effort. Because you actually have to find the number that works first. The largest number. Not just the first number you find, the biggest number. is you have to go down as far as you can. All right, questions at all about the two methods? Now, why I didn't choose to show you that one yesterday? If I was doing that 3,000 number, the 3,920, the largest perfect square in that thing was massive. It was 16 times 49. It was a really big number. I don't even know what that number is off the top of my head. But it was a really large perfect square. That wasn't in my list, right? So that's why I chose to do it by this method, because it took me less time. But yeah, the biggest number that went into 3,920, the number we did yesterday, was perfect square was 784. That's a perfect square. All right. Questions at all about the concepts, what we're doing? Now, obviously, we did square roots yesterday. I want to do cube roots, then talk about how to add, subtract, multiply, and divide radicals together, especially when they throw variables in there. How do you deal with that? Okay, let's start with a cube root. And I'm gonna probably stick with the method that I'm comfortable with, just because I think it takes less mental effort to do it. So let's do the cube root. Let's go with cube root of, I don't know. Let's go with 32. Cube root of 32. Okay, so what we're doing here, if we're doing by method number one, you're trying to figure out what is the largest numbers, or I should say the first numbers that you know go into 32. So if this is by method number one, here's what I split it up into. 32, I think of 4 times 8. I don't know why some people are 2 and 16. I'm just a 4 and 8 kind of person. Then I break down 4 even further, break down 8 even further, break down 4 even further from there. And here's what I have. Then yeah, you have to have the index number. Keep the index number. If you get rid of the index number, I come around. All right, questions on how I broke that down so fast? It's just a ton of 2's. Now, here's my question. Inside the radical, is there a triple of something?
No, not one. I was kidding. Yes.
All right, there's a triplet. It's a triplet of 2's. Again, why I'm looking for a triplet, the index number says I'm looking for 3 numbers that match. That's what the index number is telling me. So since I found a triple, you kick one of them out and you cross the rest out. That's how it always works. Only one ever exits. So there's 2 that exited, and in the inside, the 2's that I didn't circle are left. That really gets people. It's always, you always kick out 1. The rule is always the same no matter how you do my method. Kick out 1, cross the rest out. So on the inside, here's what you have. You have a cube root of 4. There's your answer. That's literally the simplified version of the cube root of 32. Now, the perfect cube list. So if you like method number 2, where you try to figure out the biggest perfect cube numbers that go into it, because maybe that method makes more sense to you. The cube list, which I'll put on my website tonight. 1, 8, 27, 64, what's the next number? 125, 216, 343, yeah, they jump really fast. So it's 1 times 1 times 1, 2, 2, 2, 3, 3, 3, 4, 5, 6, 7, and I never had to memorize past 7. Again, if you're doing by method number 2, you know where you find the biggest cube number that goes into this number, it was the number 8. The number 8 was the biggest perfect cube number that went into 32. So the cube root of 8 is 2. You just pop that to the outside, it's the second number on the cube list. So it'll be 2 cube root of 4. So it just jumps from there to there really fast. If you could figure out which is the biggest cube numbers it goes in. Okay, questions on how cube or quartic or fifth roots work? It's all the same math. Okay, are we comfortable so far? All right, now, obviously, we're going to be getting to a point where we have to be able to do this type of stuff, and we have to do it with variables in it. So, for instance, 125 x squared y z to the 4th, or let's do z to the 5th. And we're doing stuff like that. And we're simplifying. This is where my method of doing these types of problems makes it way easier to think about. Because what you're doing is you're writing down, you look for pairs, you're kicking letters out. It makes it just easier to think about in general. So for 125, I'm going to break this down as fast as I can. I'm just going to save you the time from thinking about it. There you go. That's breaking down 125, that x squared y z to the 5th, as fast as I can. So, what am I looking for? Triplets, pairs, fourths, pairs. Because the index number is 2, so I'm looking for pairs. Well, I have a ton of pairs. I have a pair of 5s, a pair of x's, a couple pair of z's. And then I'm going to kick those out. 1 goes out each time. So when you actually get to this point, there's going to be a 5 on the outside, there's going to be 1 x on the outside, there's going to be 2 z's on the outside, because 2 of the z's pop out. And left on the inside is a 5, a y, and a z. Those are the things that were left, that didn't have pairs. Now, the only difference the back of the book would have, okay, that's the answer, right? The only difference the back of the book would have is that on this variable right here, this x, they're going to put an absolute value bar around it. Why did they suddenly just randomly throw an absolute value bar, but they didn't put it around anything else?
It's an odd and even.
Yeah, it's the power. It's an odd power. What they want to guarantee is that your answer is always the positive answer, the principal square root. To guarantee that that x is actually a positive number, they put an absolute value bar around it. They don't have to worry about the z, because it's squared. It's going to give you a positive number anyways, because you're going to square it. The 5's already positive, they don't really care about that, and everything else is still a radical. Do I even care? No. If you gave me this top one, you gave me this one, I'm giving it to you. You understand the concept of what you're doing, you're simplifying it. I understand the principle behind it is that they want the positive answers. I'm not that picky. At no point in all my math have I ever had to worry about that. Now, if you're an engineer, yeah, you might have to worry about positive numbers, negatives. But for me, that got to the right answer. All right, questions at all about the concepts? All right, now today, obviously I've kind of done this massive review, right? I've done, cube roots, I've done square roots, I've done variables, I've done all this stuff. The only thing I haven't talked about is how to add, subtract, multiply, and divide radicals together. Those are the only things I haven't done. That's a very tall order. So I want to make sure that I get these done in the next 5-6 minutes. So I'm going to do one example of each type. If there's a certain type you don't quite understand, or you want to know more about it, why did I do this? You have to ask. Because I'm only going to do one of each type. That kind of gives you the rough idea what you always need to do. All right, let's start. Let's start with adding. Now, it's kind of up to you. You want me to put variables in this problem or no?
Yeah.
Yes. Okay, we'll do some variables. Okay, so let's say my problem is, let's say it's the square root of 12x y squared, and I want to add that to 4y square root 3x. I want to add these two square roots together. So I'll give you a little bit of time to write that problem down. Okay, we're going to try to add radicals. Now, here's my question. Are they the exact same radical? No, they're not. So right now, I cannot add these. Now, does it mean that I can never add them? No. What I have to be able to do is simplify each answer, simplify each radical if I can, And if you can simplify it, maybe the simplified version can add. Because the only way I can add radicals is if they're the exact same radical with the same leading coefficient, like variables out front. So if you have variables all over the place, you have to have the same variables outside, you have to have the same radical behind it. The radical behind is the big thing you have to match. So on this one, I'm going to simplify the 12 here. So the 12, I'm going to do this by my method. So 12 is 2 times 2 times 3. We have an x, we have a y and a y. This number here, I really can't even break that down because 3 and x can't even be broken down any further. There's no pairings for 3, there's no pairings for x, so that's pretty much where it sits. Okay, let's keep going here. Is there any pairs on the inside? A pair of 2's and a pair of y's, right? I'm going to kick those out. So there's going to be a 2 on the outside, there's going to be a y on the outside. I still have the square root symbol. There's a 3x. All right, so now, here's my question. Are they the exact same radical now? Yeah. They have the exact same variable outside and the same radical. This is what I'm looking at. Do they exactly match? If they do, all you do is you add the leading numbers up front.
So the number doesn't have to match on the outside?
No, the numbers don't have to match here. It's the variable and the radical have to. So everything. So if there's multiple letters and multiple things inside the radical, they all have to match. And then all you do is to add, is you're literally adding the numbers I circled. Because those don't have to match at all. It can be positive, it can be negative, it can be fractions, decimals, it doesn't matter. But those numbers you have to add. So what's 2 plus 4? 6, y squared root 3x. That's your final answer. That's how you add radicals together. Notice the radical didn't change, the variable didn't change. You only add the numbers out front. Because that's the only numbers I know. Everything else is an unknown, so I can't add it.
So that was just the same for subtraction too?
Same with subtraction. So if I made that a subtraction problem instead, your final answer would have been a negative 2. Because 2 minus 4 would have been the only difference. Questions with that? Now, if there's anything that's off, even if a power on the y is off, maybe this is y squared, then you can't add or subtract. They have to be identical letters, identical radicals. Okay, questions? Perfect. That's my one example. Those are kind of the easiest ones to talk about. Okay, multiplying. Radicals. You can multiply any type of radical you want together. I don't really care the type. So they could be different numbers, different letters. It doesn't really matter. Let's say I'm going to multiply 16 times let's say I'm going to multiply by 5x squared. Let's say that's what I'm going to multiply together. So you can multiply any types of radicals together. I don't even care if they have numbers out front of them. We can still multiply them. Anything that's multiplied can go together. It's like the law of exponent. You can multiply anything you want. So when I multiply these together, here's what I get. I get 2 and 1 radical, and you take 16 times 5, which is 80, x squared. Right? You can just multiply the 2 radicals together and make a really large one. Then you got to simplify. After you multiply, then you can simplify them. So at this point, what I would do is now I'd break down the 80. Well, that's 4 times 4 times 5, which is 2 times 2 times 2 times 2 times 5 times x times x. If I kept going even further, and then I have a bunch of pairs. So I have a pair of 2's, I have another pair of 2's, and I have a pair of x's. And those would be fired outside. So on the outside there's already a 2 sitting there, but these other ones are going to join it. So I'm going to have another 2 that joins, another 2 that joins, and an x that joined. And on the inside, we still have 5 that's left over. 5 didn't go. Now there's other ways to do this. Obviously, some people like to simplify the radicals before we even start. You can do it that way too. So I could just simplify this radical. Square root of 16 is just 4. Would make it a lot easier, but I just multiply them. Keeps it in mind, that way you can see if you have any pairs. And then the final answer is 2 times 2 times 2, that's 8. X radical. Everything is always
I was
multiplied.
gonna square it. You'd actually do it.
Okay, questions on multiplying. Okay, very last thing today is when you have fractions. This is the hardest thing possible for me to teach. When you have fractions and you're dividing radicals. If you can simplify the radicals, do it. If you can't, you have to try to get rid of the radical off the bottom. It's called rationalizing. Let me give you an example. All right. Let's say I had square root of 6x over the square root of 12y. There's two ways to write this. These mean the same thing. I can write it with one large radical. One large radical or two separate radicals. They're the same thing to me. So, when you start, you could just simplify if you wanted to. Some people like to simplify. They like to go, okay, this is 1x over 2y. They just simplify the 6 and 12, right? That's fine. You could do it that way, and then you could start your problem. But you'd have to go back to this form in a minute. So I don't really care if you want to do it that way. Because you have to go to separate. So if you want to change it back, so you can change it back to this. I'm fine with that. Some people like doing that, like simplify it before they even start. Some people just start here and go from there, because you're going to get the same answer in the long run. So it depends. You guys want to do the simplified route, or you just want to stick with the original?
Stick with the original.
Original? Okay. Sorry if you said otherwise. I don't like original. Okay, so we're going to stick with the original. So, at this point, you cannot leave a radical on the bottom. There is a radical on the bottom, do you agree? Like that doesn't like simplify all the way. So what you do is I break this down inside the radical without simplifying it yet. I just break them down on the inside. This is the way that I do this. Because my whole goal is to get rid of the stupid radical off the bottom. I don't want a radical, a square root on the bottom of a fraction, because it is literally impossible to type in a very simplified calculator. So what you want to do is you want to rationalize it. Rationalizing means make it a fraction without a rational number on the bottom. So irrational, I should say. So, all right, on the bottom, what type of radical do I have here? Square root, cube root, quadratic root, what do I have? Square root. Now, do you agree the index number is a 2? Yep. I'm looking for pairs. Do I have pairs on the bottom? 1. I have one pair, a pair of 2's, right? I need more pairs for that thing to simplify. What do I need to multiply on the bottom to make the extra pairs?
3y.
I need a 3 and a y. Does everyone see that? That means everything will have a pair. So that's what I need to do. I need to make sure that I know what I need to multiply by that will add extra numbers and letters to the bottom so that everything has a pair. I need to multiply by 3 and a y so that everything will cancel out on the bottom. When you do that, you have to multiply by the same thing on the top. Because technically what I'm doing is I'm multiplying by the number 1. If I multiply anything by 1, does it change the number?
Yeah.
If I multiply by 1, nothing changes. It's still the same value, right? 1 times I think it's still the same number. Well, what I'm actually doing is I'm multiplying by a fraction, which is 1 over 1, which is root 3y over root 3y, which is the number 1. That's what I'm multiplying by. And when you do that, it will simplify the bottom. The top I could care less about. The top, here's what I have on the top. When I multiply these radicals together, because you can just make it one large radical. But on the bottom, here's what I have on the bottom now. I have a bunch of 2's, a 3, a y, and another 3 and a y. And now you can start to see that I have multiple pairs, so you can rearrange them. I don't really care the order you put them in. But you start to see that the bottom will eventually turn out to be like a perfect number, right? Because on the bottom I have a pair of 2's, a pair of 3's, and a pair of y's on the bottom. So when you kick those out, a 2, a 3, and a y will be outside the radical on the bottom, and there's nothing left on the inside. Because there's everything had a perfect pair.
I did not get this last year.
So this is my easiest way of doing that. Just get rid of all the numbers that don't have pairs, right? On the top, is there any pairs on the top? a pair of 3's on the top. So I'll kick one of those out. And everything left on the inside just stays where it's at. Final answer. Can anything simplify top and bottom? That's not a radical. Does anything cross out?
2
Top
times 3.
3's? And that's it. You can't simplify anything in the radical. So your final answer is literally this. It's square root 2xy over a 2y. That's your final answer. That's why I've been teaching you the method I have been, because I believe that it's the easiest way to do radicals without having to think about it. What I multiply by it, the extra step I add, that way everything on the bottom will cancel out and there's no radicals left. That's why I do this step. Okay, homework's on the board, page 43. If you need extra problems, like this didn't quite match with you, I can do more. I have tons of marker board space. I can do more with you if you want a certain type. If you have questions on your homework, never be afraid to throw it out there, we'll talk about it. But you're just simplifying a lot of radicals. I will probably do a few more examples tomorrow in class, but it's due Friday. Because I might do some with negatives.
Oh crap, that essay threw like